When you think about the most efficient delivery service in the world, what comes to mind? Maybe Amazon or FedEx? Well, the truth is, the most incredible delivery network isn't out there. It's in you, and it's running right now. So let's take a closer look at this amazing system, the cardiovascular system.
Okay, let me ask you a quick question. What is it that runs 24/7, never takes a holiday, never even stops for a coffee break, and powers your entire life from the moment you begin to exist? You guessed it, it's your heart. And here's the part that just blows my mind every time. This absolute powerhouse, this engine for your entire body, is only about the size of your clenched fist. That's it.
All right, so let's dive in. What exactly is this delivery service? We're going to look at what it's made of and what its absolutely critical mission is.
So at its core, the system is a team of three. You've got the heart, that's the pump. You've got the blood vessels, those are all the highways and roads. And you've got the blood itself, that's the fleet of delivery trucks. Its job is pretty simple but vital. Deliver all the good stuff, like oxygen and nutrients, to every single cell, and then haul away all the trash, like carbon dioxide.
Now for the fun part. Let's go on a little tour inside the main headquarters, the central pumping station for this whole operation, the heart itself. Okay, so the heart is basically this incredible four-chambered muscle. But what's really fascinating is that the two sides are not created equal. The left side is way more muscular and powerful than the right. And why is that? Well, think about it. The right side's job is just to pump blood next door to the lungs. Easy enough. But the left side, it has the massive task of pumping blood to your entire body, from the top of your head all the way down to the tips of your toes.
So what are these four chambers? We've got the right atrium, the right ventricle, the left atrium, and the left ventricle. You can kind of think of them as two sets of receiving and shipping docks. The top two, the atria, receive the incoming blood, and the bottom two, the ventricles, are the power pumps that ship it back out.
And here's a great look at that layout. You can clearly see the atria up top, the receiving areas, and then those much more powerful ventricles at the bottom. This four-chamber design is just brilliant, really, because it ensures that oxygen-rich blood and oxygen-poor blood never, ever mix.
So the heart is the pump. But what about the roads? Let's zoom out and take a look at the vast, sprawling circulatory superhighway that carries all that blood.
You've basically got three main types of roads in this network. First, you have the arteries. They carry blood away from the heart. A good way to remember it is A for away. Then you have the veins, which bring all that blood back towards the heart. And connecting them are the capillaries. These are the tiny little neighborhood streets where the actual deliveries of oxygen and pickups of CO2 happen, right at your cell's front door.
This whole superhighway really runs on two main loops or circuits. See the blue vessels? That's the deoxygenated blood going on the pulmonary circuit. It's just a quick trip from the heart to the lungs to get refueled with oxygen. Once it's loaded up, it turns red, and it heads out on the much bigger systemic circuit to deliver that precious oxygen to the rest of the body. But, a pump is just a piece of muscle. It doesn't just work on its own. It needs a power source. And this is where things get really cool. The heart has its own built-in electrical system. Take a look at this. This is a map of that electrical grid. It's not just muscle, it's this incredibly sophisticated network of special cells that actually create and conduct electrical impulses. This grid is like a tiny, perfect conductor for an orchestra, telling each part of the heart exactly when to squeeze to create one single, coordinated heartbeat.
So how does that journey work? Well, every single heartbeat follows this exact path. It all starts at the SA node. That's your body's natural pacemaker. It fires off an electrical signal. That signal then travels to the AV node, zips down a pathway, and then spreads out through this whole web of fibers that tell the big, powerful ventricles, okay, squeeze. It's this beautiful electrical cascade, and it happens in a fraction of a second.
And how often does this incredible electrical dance happen? Well, for most of us just sitting around, it's firing off somewhere around 70 to 72 times every single minute, nonstop.
Okay, so we've got this amazing critical system running. Obviously, we need ways to check in on it to make sure everything's working okay. Let's talk about two of the key vitals you've probably heard about, blood pressure and the ECG. You ever get your blood pressure taken and they say something like, it's 120/80? Ever wonder what that actually means? It's really simple. The top number, systolic, is the pressure in your arteries when your heart contracts, when it's squeezing. The bottom number, diastolic, is the pressure when your heart relaxes in between beats. And you can see the healthy range for both right here. And then there's this famous squiggle.
The ECG, or electrocardiogram. Now, it might look like a random line from a lie detector test, but it's not random at all. It is a perfect graphical signature, a printout of that electrical journey we just talked about, tracking the impulse as it moves through your heart with every single beat.
And every part of that signature has a specific meaning. That first little bump, that's the P wave. That's the atria, the top chambers, contracting. Then you get that big spike in the middle, the QRS complex. That's the main event, the powerful ventricles contracting. And that last little bump, the T wave, that's just the ventricles relaxing and resetting for the next beat.
And if you really want to wrap your head around the sheer scale of the work this system does, just think about this. When you're resting, your heart pumps about 5 liters of blood every minute. To put that in perspective, that's like pumping your body's entire supply of blood around every 60 seconds.
So when you really stop and think about it, this incredible delivery service, this pump, these highways, this amazing electrical grid, it all runs tirelessly every second of every day,